Okay, so sets would be rational, integer, whole number, natural, irrational, real, and not real. Yeah. Yeah. So the key is where it says sets plural. Okay, so I think I had a bad decimal after my class yesterday. This is the same as 1.25. That's a real number, and that's a rational number because it's a terminating decimal. You don't have to write that parentheses. I'm just saying. That's it. Any other ones for number 2? Okay. If I had to write the square root of 20 as a decimal, I'd have to use squiggles because when I write it down, I have to round it. It doesn't equal anything exactly. It's something between 4 and 5 because the square root of 16 is 4 and the square root of 25 is 5. So the square root of 20 is something in between there. Emily, here, did you square root it? 20. You tell me the square root of 20? Jade, what's the square root of 20? 4.5. That decimal goes on forever and ever. So we call that irrational. It's like your mom. When she's going off after school, she won't stop going off. Mom, you're being irrational. Don't say that to your mom, by the way. Doesn't calm anybody down. Moms are never irrational. Doing their job. Number 4, we're going to call that a real number, a rational number, and an integer. Number 5, the square root of 25 is 5. So this is just like 62. Let's see if I can copy and paste it. I don't want to write it again. Not bad. Not bad. Okay, number 6. Let's hear from some of you. Gabby, you do number 6.
I got rational integer. Right?
No,
Yeah.
it's not an integer.
Oh,
Did you really write integer? Yeah, it's not an integer.
Rational, real, and integer.
No, it's not an integer. If it's not like an inch mark on a ruler or a negative inch mark on a ruler, it's not on there. So it's no decimals. Integers don't have decimals. Number 8, the square root of negative 49 is not a real number. That's all we're going to say about it. Okay, it doesn't get any of those classifications. Yes. Yeah. Sorry to confuse you. So we're just going to call that not a real number. So you can't have, and let me just put a star and explain that. You can't have a negative under the radical. This is the smallest writing. You probably can't even read it. So I mostly just wanted to highlight the difference between 7 and 10. 7, not a real number because the negative is under the radical. 10 is a green light, go. Totally fine. Okay, number 8. Franco, do you want to try that one? Tell me one, any one set it might belong to. Nope. Go ahead. Nope. Repeating means it's rational. That's it. That's it. Just real and rational. Yep. You'll remember it now. Yep. That's a good thing. No, it is real and it is rational. Number 8. No, it's not. It's not rational or irrational. It's none of it. If it's not a real number, it's none of those things. Then can't make it. Can't make it into the group. I better come up here for 9. 9 over 3. Yes, go for it. Yes, it's a whole number. So it's also real, natural. It is rational. Rational. One more. What's the last one? No, not irrational. Integer. Number 10 is actually negative 12, right? It's actually negative 12. So it's real, rational, integer. Not a whole number because whole numbers are positive or 0. Okay, I do hear some confusion about integers and rational numbers. So integers are just whole numbers and their opposites, and rational numbers will include decimals that end or repeat. Does anybody have any questions right now? Anybody can clarify anything with a great question or comment? Okay, then get out your workbook. We can continue to try to make this make sense looking at last night's homework, page 3, 1 through 25I. That's it. That's the reminder. Yeah. All right, I am gonna let you guys go through and check these with one another, and then I'll take questions.
We don't have to do nothing for the example.
Correct. You do not have to write this down. Take pictures. Maybe you think you don't want it, and you actually do. A picture will do that for you. It'll also be on a video in Schoology. There's a video showing them. It's not really as good as notes. So we're just going to be solving equations, multi-step equations, opposite operations, getting a variable alone, finding x, finding w, yada yada. So step one in solving equations is, if possible, to simplify the left and right side of the equal sign by distribution and or combining like terms. So there is a systematic approach to solving long equations, and sometimes you can get through to algebra 2 kind of willy-nilly doing opposite operations. You get the right answer, but having a more like clear approach to it, a more consistent, uniform way of doing it is good. So what we'll practice in here is always just simplifying the left completely and the right completely before moving things around that equal sign. That's all this is saying. Step 2, you want to bring your like terms together. Collect like terms on one side. Start with the variables. So if I had the option of subtracting 2x to both sides or adding 10 to both sides, I would start with bringing x's together. You're going to continue to try to isolate your unknown variable using addition or subtraction. And then isolate using multiplication or division. Okay, go ahead and try the first one when you're ready. I need more time. So looking at this equation, there's a lot to do to simplify that left side. Step 1 is to simplify the left and right side completely. So we are going to simplify the left side using the distributive property first. And then we're going to continue to simplify the left side by combining like terms. And now the left side has been simplified as much as possible. There's nothing more I can do here. There's no like terms. We'll subtract 33 from both sides. So like it said, I think in step 3, it says, isolate variable by doing addition or subtraction. So we move that constant first. And now last is that isolate variable doing a multiplication or division. This is -6 times a. The opposite of multiply is divide. Anybody else get a +3? Okay, gotcha. So how could we check this? We could plug it back in here and here, simplify using order of operations, and it should be 15. I'll give you guys some more time on the next one. There you go. There, that's all of them. Common denominator if necessary. Not doing decimals here. After you simplify the left and right side completely, you're going to bring the variable to one side of the equal sign. Move that variable first. So when you have your variable on both sides of the equal sign, they want to be together. They shouldn't be separated. You want to collect them together. So we have options. I don't really like having negatives, so I'm going to add 7/9 to both sides. Who decided to subtract 4/9? You can. It's fine. I'm going to add 7/9 here, which cancels it out. And I'm going to add it here. So 4/9 combined with 7/9 makes 11/9. Keep the y with it. Everybody okay? All right. So now the constants should be on the same side of the equal line. It's a +5, so we'll cancel it here by subtracting it. Okay, and now we want to do some sort of inverse here. We want to cancel this fraction out. So we'll use the multiplicative inverse. If we multiply this by its reciprocal, 9/11, it will cancel leaving the y by itself. And y equals -13 times 9/11. -107/11.
I got 117.
117.
I think 117 or 11.
90 plus 27. Leave your answer in fraction form. Does it reduce? Okay, yeah, or your mixed number. Okay, here we go. I wanted to put one right in there with fractions number 3, more fractions. Give it a go. Who's got a question on this one? You can ask it. I think, and I'm looking. Yeah, I was gonna see how it looks a bit easier, but it really doesn't. I don't like that at all. I gotta get into this one. You know what I want to actually do is can I? Anybody feeling like clearing fractions here? No. Yeah. Yeah, you could clear fractions multiplying everything by 12x. Anybody think of doing that? We'll spend time on that this year. You could clear fractions here. We'll spend like a week on it. But for now, let's just try to get x alone, right? Subtract 1/4 from both sides. So I'm just going to come to the side here and do my fraction work. How do I do 7/12 minus 1/4? Well, my common denominator will be 12. So I just have to change the second one. If I multiply the bottom by 3, that'll create my common denominator. So I'll multiply the top by 3. So this is 7/12 minus 3/12 will give us 4/12. And then we can reduce it. We'll divide the top and bottom by 4 to get 1/3. So that was just my sidebar. So now I have 1 over x equals 1 over 3. And so when your x is in a denominator, you kind of have to go out a long way. I'm going to start multiplying both sides by x to get it out of the denominator. That'll cancel it here. Leaving 1 equals x over 3. 1 over 3 times x over 1, x over 3. Last step. And it turns out x is 3. So that's not your algebra 1 equation. Should feel a little bit more challenging. Who's got a good question on that one? All right, we don't have time for that online activity today. I'd rather just give you time to jump into this assignment. So check out the backboard, start it in your groups. They start out, your first 2 don't have fractions, and then the next 2 do. So try to get into some of that fraction work in your groups. So sorry, you can log out of those Chromebooks. We did not have time. Sorry. 100%. No credit if you don't show where. I know, but you'll find them. You'll be glad you did. And actually, let's say that you're hired as an engineer. In your firm, if you don't back up your work, right? Or in your accounting firm. If you don't back up your accounting with actual work, they will not pay you, right? So you can't write a story and only tell the ending. So when you just write an answer down without the work, you miss the plot. It's not as interesting, is it? We don't want to miss the plot, the most interesting part. I want to see more than the ending. I want to see the work.